Hello, happy St. Patrick's Day. This is the last talk you have to listen to before you can party with green hats. So, my name is Bill Venners, and I wanted to talk about this library called Scalactic that grew out of Scala Test. And essentially, Scala is a very unopinionated language. It allows a lot of different styles and a lot of different ways of doing things. And Scalactic kind of is more opinionated, and I wanted to just describe what that is. And I really wanted to boil it down to something really simple. And so I think the best description is that the opinion is you should use types to achieve quality. So where Scalactic came from originally is it grew out of Scala Test. And Scala Test is a test framework which is essentially allows you to achieve quality through writing tests. And there were a lot of things that over time people asked for in their tests. They asked for enhancements to Scala Test that they also wanted in their production code. So an example is in testing you often say compare things for equality. So they wanted a sane type check. They want a compiler error when you get like compare an option of string with a string, but they also wanted that in their production code, right? So that kind of stuff we carved out and put into this library. So really Scala Test was quality through test. Scalactic was quality through types. And the other thing that happened recently is we created a compiler plugin, which is a product, which is quality through static analysis. And that actually grew out of Scalactic. So I'm going to kind of talk about, in this talk I want to talk about, give you one specific example of how we achieve quality through types with Scalactic, and then some examples of like where it didn't work out to use types. So, okay, so the example is called AnyVals. And what this is coming out in 2.3, which is the next release of Scala Test and Scalactic. Scala Test and Scalactic are released together. They have the same version numbers, so that you just keep them in sync, and so they come out together. So the next release is 2.3 for both of them. And so we've added this package where we have these types that basically allow you to express in the type system that an integer or a float or a long or double is either positive, that's the ones on the left side, like posint, or positive or zero, that's posient, right? Positive plus zero. So I'm going to give a quick demo of that, and let me see if I can get out of here. Quick demo. Yeah, version 2.3. So what I am going to do is import org.scalactic.anyvals, and then I can just say posint 42, and I just get posint 42. Now, if one thing I can't do is I can't say new, because the constructor is private. So what I'm really saying here is .apply. It's a factory method, and it is implemented in terms of a macro that actually checks at compile time to see. Whoops, hang on a second. I have my news sticking out here. Okay, so it checks at compile time to see if it's positive. So this is not a runtime error, this is a compile time error. Oh, you can't see that far down? Okay, I can move it up. Whoops. I may be able to move it up. Yeah, you got it. Okay. Better? So essentially this is a compiler error, this error right here. The macro looks at the literal value, and did I miss the point? Okay. The macro looks at the literal value, and it can tell at compile time that it's not valid, right? And then if you, essentially if you say val x equals 42, val y equals minus 42, and try to actually pass a variable that's an int there, it can't prove at compile time that it's either positive or negative. So what it does fail to compile with a compiler error, but what it says is you need to use a different factory method called from. And so what that does is it gives back an option if it's some if it's positive, none if it's negative. So there's no way in this type to get a exception, essentially at runtime. There are implicit conversions in both directions. So if I say val I colon int equals, let's say, what's one of the ones we got going here that was good? Posint 42 is called res3. So let's say it equals res3. That's actually a posint. It will just implicitly convert it to int because that's a widening conversion. And it's called anyvals because it's actually an anyval, so at runtime it's just an int. So there's really no boxing overhead, unless you would need to box the int anyway. But in the other direction, if I say val posint, let's say, posint equals 32, that's not a widening conversion because I'm initializing with an int, which has a much, it can also be negative, right? But what happens is it's still, the implicit conversion is applying that macro to make sure that it's valid. So, so that's the idea of anyvals. And I wanted to give you an example of how we used it. So we actually had to make an enhancement to Scala Test because Scala Check changed something. And Scala Test integrates with Scala Check. And what they changed is the way you configure a property check. So this is Scala Test code that's been around since 7 years ago. It's how you, it's a little object that allows you to supply configuration parameters for Scala Check tests inside a Scala Test suite. And there's 5 of them: min successful, max discarded, min size, max size, and workers. And it turns out these were all ints in Scala Check, so we made them ints here. And then I added a bunch of requires right here because I wanted the, I never wanted you to be able to create an invalid property check config. So property check config has a bunch of requires that says, you have to pass a min successful greater than 0. You have to pass a workers greater than 0. Workers is the number of thread that's going to be operating. So basically I encoded these constraints for positive or 0 plus positive in the requires. And what that means is if you have an instance of property check config, then you know that these numbers are positive, right? You know they're valid. There's no way to create one of these where it's not valid. But if you pass in a bad number, it blows up with a illegal argument exception. So what we changed it to in 2.3 is this. We decided to try to use these values and put it in the type. Right? So we moved it from the require, which is a runtime error, into the type, which means you can't get a runtime error. And that makes it safer. So here I was able to get all but one of these requires by just saying min successful is a positive int, and like min size, 0 was okay, so that's posy int. So we just did that and got rid of the requires. And there was still one require here that we had, which is that min size has to be less than or equal to max size. So that one I didn't get rid of yet. But this second line was actually changed in Scala Check. That's why we had to do this enhancement anyway. So it was just the timing was such that we went ahead and tried out these positive integer types. So I looked at this, and so one of the ideas of using types to achieve quality is you want to get rid of bugs, right? And so if this require ever throws illegal argument exception, what that means is that at runtime we have discovered that there is a bug in our code, right? So you want to actually try to find that bug at compile time. And the problem is I didn't have a way to say min size less than max size at compile time. But what I realized is if I change that max, instead of having a max size, I just gave an integer that's positive that you add to min size to get to max size. That would solve that problem. So by just changing, I'm going to change max size, the second to last one, to size range, which means this is how much more than min size is the max size. And now that's a posy int. And I've gotten rid of there's no way to create one of these that you can get a runtime error at runtime. And this is just, this is test code, so it's not that big of a deal. We'll just fail the test. But that's the idea, is that you use types to get rid of these potentials for bugs, right? Okay. So the other thing I was able to get rid of, because I'm very, well, I like to write tests for some reason, so I had tests for these requires to make sure they actually worked. So when I inserted the require, I had a test that made sure that the require threw illegal argument exception if I passed in bad data. So I don't need those either. So what I was able to get rid of was requires and asserts, essentially. And that's the value of it. And so the other thing that we have in Scalactic Antivals, this package, is something called compile-time assertions to help you write your own. So we've got, in the first version, we're just releasing 8 of them, but you can imagine all kinds of other things where you might want to enforce a compile time that it's a valid subset of some type. Well, that's interesting. I have managed to lose my changes, but that's, I'll just go with it. So what this is if you want to have an odd integer, you basically want to have a type that says this number is odd. What you would say is you just create a final class odd int that extends any val, and it contains the value int, and then you can add methods in there that could be called on that thing, but actually at runtime its underlying is int. And then you actually make a companion object with the apply and the from. So there's the from method that returns an option and the apply method that actually just returns the type. And it is implemented in terms of a macro. So what you then have to do is you actually have to write a macro. So basically this is done with the macros, and macros can be hairy. So what we try to do is make it simple. You extend compile time assertions, and what you get is a way to say do an assertion at compile time inside a macro, essentially. So Scala Test has a bunch of ways to do assertions. Scalactic has actually a way to do require that gives you an error message, that it analyzes the expression, just like Scala Test analyzes the expressions and tries to give you a nice error message. Scalactic will analyze the expression of your require and try to give you a nice error message. So this Scalactic Antivals is another kind of assertion that actually runs at compile time and enforces that a literal value is within some constraint, like it's odd or it's even. Okay. So I'm going to just check and see. Yes, good. All right. So here's an example. If you had made an evenint, essentially, then you could get rid of this require. I mean, what I have here is a method that takes an integer and requires that it's even and then cuts it in half. Right? So here's a require that shows there's a possibility to get an exception at runtime. So what you can do to change that is just use evenint. And the reason that there is no require anymore is because I'll ask you guys, why don't I need a require anymore? Yes, Will. Compile time failure, okay. So you believe there will be a compile time failure? This is great. He believes already. I have a believer. So, do you think that it is proven that it will not compile if what? Compilation is approved. So essentially, yeah, that was kind of the thing I wanted to talk about, because I wouldn't say that it proves it. I would say that I trust it. Because if there's a bug in posint, in other words, if I didn't test it well enough or I screwed it up, it actually could fail. I mean, I could actually have a bug there. And occasionally we find bugs, right? So what we do, I mean, what I think, because I'm sort of think a lot about testing, one way to think about types is they allow you to focus your tests. So I only have to test this constraint of being positive in one place, which is now posint. then everywhere else where I had that constraint, which frankly that's all over the place in most code, you can just take that type, and now you don't have to write the require and you don't have to write the intercept. Right? So you don't have to test it there. You just I test it in this one place. And then in this case, what I try to do is make it convenient, because you just pass an int that's positive and it will compile if it's a literal. And so it's very easy to use in the source code, and then at runtime you don't actually pay a performance penalty, hopefully, because it's an any-val. Right? To the extent any-vals do that, this will do that. I think, just to summarize part one, and I was trying to boil down the opinionatedness of this library. It's just that you should use types to achieve quality, and that's like a big idea of Scala. But you don't have to do that with Scala, but that's what I think it's like we have this very rich type system, and that's what we should use it for, right? And what that really does is it reduces the need for tests, but both assert and require, because a require is like a little test in your production code that runs every time. It's like a precondition. So you want to get rid of those where it's practical. So sometimes it isn't practical, but that's what I try to do. Okay, so I have some stories. That was part one. That's sort of like the opinion of Scalactic. Not too earth-shattering, but that's what it is. Use types to achieve quality. So before I go to part two, I wanted to tell some stories, and I had there's three of them actually. One of them requires that I show you this interview I did with James Gosling in 2003. Right? James Gosling invented Java, and in those days I was writing articles and interviewing people, and so I interviewed James Gosling, and I named the article Visualizing Complexity. I'm not sure why, but in those days I was sort of focused on Java, so I don't know. But this is just one question that I asked him, and he gave me an answer that surprised me, I didn't expect, and that I always remembered. And what he said was that essentially I asked him about, or I'd heard him say that in these big enterprises you can't turn anything off because you don't know what is connected to it, like what is calling into it. So they'll think something is not being used and they'll shut it off, and then 2 months later something every 2 months will actually try to access that thing, so you've broken the distributed system. And he said that it's a very hard problem to do that kind of self-healing distributed system, and that the World Wide Web, which in 2003 was, I think this is, actually that's about when the .com thing started crashing, but it was still kind of new. And he said that wasn't the first hypertext system, that was actually invented by a guy named Ted Nelson, who created something called Xanadu. And what he did is they went off and did the usual computer science thing, which is to try to solve all the hard problems and make it perfect. All right? And what he tried to solve is the self-healing thing. So if I have 3 links to this resource, and we remove this resource over here, that those links would automatically get healed and point to the new location, right? And he said that people have been trying to do that for 20 years and failing, and that what he thought Tim Berners-Lee did that was brilliant was to say, I'm just not going to try to solve that problem. That's too hard. I'm just going to solve the problem of how do you grab a resource. So he invented the URL, right? He invented HTTP. And that took off. Even though it wasn't perfect. You go to a URL and you may get 404 page not found, right? So what he was saying basically is that sometimes it's better not to solve every problem. Okay, so that's one. So then another story is a guy named Jim Waldo. How many people have heard of Jim Waldo? Not very many. So Jim Waldo invented Jini. How many people have heard of Jini? Okay, a few more. So he actually invented Jini. I'm going to sit here because I'm telling stories. So he invented Jini, and I thought that it was beautiful and elegant and really simple and nice, and like there was this Java Spaces API that had 5 methods in it, so it was really nice. And Jini didn't really work out in the marketplace. But I was part of that community, and we all became friends. And a few years ago, I was in Boston, so I called him and this other guy named Ken Arnold, who designed Java Spaces, and we met for beer. And we were like bunch of old, three old guys talking about why things didn't work out. It was kind of like that. And what we were doing is saying, well, my theory was this, my theory is this, my theory is this, right? And it was a private conversation, so I asked him this week if I could relate this story, and he said yes. His opinion was that it was a mistake to put security into Jini. So there was this, originally when Jini came out, it did not have any way of doing security. So you talk across the network, there was no way to authenticate, right? And so you could use it behind a firewall, but out in the open, if you're worried about security, it really wasn't appropriate for that. And because J2EE was the enterprise story at Sun, they positioned Jini as something for devices, so it kind of needed that security, so they went ahead and did it, and it was a very, very difficult engineering problem. But they did it, and it was really an awesome engineering accomplishment. But what happened, and what Jim said, is that we lost the simplicity, and they did lose the simplicity. It was much more complicated. And he thought that was a mistake in hindsight, that messed it up and made it much harder for it to be adopted. So that's kind of another example of I didn't expect him to say that either. So the third and final story is just the Gordian knot story, which is actually a myth that there was this big knot that was tied in the middle of town, and the soothsayers said that the person who can untie that knot gets to be the next king, right? So everybody's going around trying to untie this knot and failing. And Alexander the Ordinary came along, and he said, well, he took his sword, he goes whack, right, and it goes chink. And then he became king, and that's how he became Alexander the Great. So it's really, I don't know, it's like probably didn't happen, but that's the story, and it's about thinking outside the box, or sometimes there's another way to solve things. Okay. So anyway, that was story time. So what happened, what I wanted to show was, the reason I brought that up, play slideshow, is that I have been, people ask me for these type checks for equality comparisons. And in version 2.0, we brought out this triple equals things that addressed it. And in 3.0, we enhanced it. And the triple equals is even nicer in 3.0. But there were three places where I didn't know how to solve it in 2.0, and that was for matchers. So for equal, be, and contain matchers, it was really a much harder problem, because you can actually combine these with logical expressions. So, but it was what people wanted, and it just seems like a waste of time if you compare a string and an int and it doesn't give you a compiler error. And lots and lots of people out there using matchers, right? So in 2.0, essentially, well, I can just show you an demo. Let me show you that one. That would be, this guy. So if I just say, do I have matchers here? One should equal high. So there's an example. I can say one should equal high, and I get instead of it not compiling, I get an exception, right? So I wanted to fix that. And it's a really long story, and I'm not going to go into where I had to go to do it, but what I'll show you is just the output. Actually, I can show you a demo here. Do I have checked equality in here? Yes. So I can just say one should equal high. So now you actually get a type error in 3.0, in master, in Scala Test master on GitHub, which says could not find implicit value for parameter type class 1 : org.scalactic.enablers.evidence that string # can equal int. That was the simplest I could make it. Now, there was a couple of problems. One is I had to partially apply a type, which was really thorny. So let me show you what that looks like here. Play slideshow. essentially, I need to fill something in this matcher factory type parameter that's a type constructor that holds one thing. And by the way, I'm going to purposely lose you, but I'll come back to why, all right? So that's what equality is. It's equality of t, so that has a type constructor that takes one type. To do a type check for equality, I need two types. I need the left type and the right type. So I actually have to capture the left type, the right type, but I put it on the left because that's what I had to do. And then on the right, I leave it unspecified. So this evidence that string # can equal fits the form that I need there, which is a type that is a constructor that takes one type, which is the left-hand type. And when you pass all this thing to should, it will actually look for an implicit evidence that string can equal whatever the left-hand type is. And so that's how you end up with this kind of error message. So I didn't like the complexity of it. And it started to remind me of these stories about you don't have to always solve every problem, and it was a mistake. He actually felt like he messed up. Basically, you can mess up a library, right? You can actually go in the wrong direction. And so even though I've been working, we worked really hard on this, I was concerned about the complexity. It is safer, but it's more complicated. And for me, simplicity is, it's like a feature of Scala Test. I want it to be simple and easy to use. And this kind of crosses a line. But what was worse was we measured the compile time, and I had to add implicits to do this. That's how it's like the magic behind the scenes is implicit lookups. And the worst one I knew should be, because in 2.0, 2.x, should be has no implicit lookups. And in 3.0, it's going to have 3, right? And there was a way to, I worked on trying to figure out ways to optimize it, and so in most cases I can get it down to 2. And this is actually the compile time. We measured, this is 2.0, so I'll look at here. You see 97.45 milliseconds and 14.0, that's like 40% slower, 50%, I'm kind of ranges. Which is too much. There's just too many people using this. And it's not actually worth it. It's not a good deal for me to give you safety to save you time now and then. But all the time you have to wait more for every expression, right? Because most of the time you don't make that mistake of comparing an int and a string. But even the worst case was, it's takes twice as long to compile. Now this is very rare. This is when you use logical expressions, and most people don't most of the time. But finally, basically, I actually checked this into master, and I was going to release it as soon as I could get it to compile fast enough. And every time I had an idea, we could get a little bit faster, but we really have run out of ideas, and I finally come to the conclusion that it's the wrong thing to do. So essentially, that was, we're not going to release it. And then there was some other things that people were wanting this in their production code, and there was this post by Martin Odersky on Scala internals a few months back. It was 4 months ago, where he had kind of come up with some ideas for how to get double equals to have a type error, right? And I saw this, and the concern I had here was kind of the same thing, that double equals is really simple and easy for people to understand. And this loses that simplicity, even though it addresses that problem. So that was my concern, and what I said, I was participating in this discussion, what I said was that if I just say 1 equals high, this is just Scala, the compiler notices that this is probably a bad idea and gives you a warning. So my idea was, well, why don't you just make the compiler a compiler flag that says make that an error. And now the compiler is preventing it, but you don't have to complicate double equals. And then I looked, I thought about it a little further, and it turns out there's, if you do these the other direction, you actually don't get the warning. So the compiler would have to be enhanced, and there's actually a lot of different little rules that you have to worry about, if you say big int 42 equals big decimal 42, it's true, because these two types know about each other and cooperate to achieve the symmetry that's required by the equals contract. So you could make type, you could make foo and bar, and they could cooperate, and actually it could be true when you compare a foo and a bar, and how would the compiler know that? It has to have a config file. So it was the wrong tool for that job, I thought, but I thought maybe that's the right way to do it. And so we went and tried writing a compiler plugin. So that's where SuperSafe came from. That was the compiler plugin. If you say, this is with SuperSafe in, if you say 1 equals hi, you get the warning. The compiler warning is still there. We couldn't turn that off, but you'll get a compiler error. And it works the other direction too. But it allows things like big int 1 equals big decimal 1, because that can be true, and I'll make it true. Or 1L. I mean, the other thing that cooperates is numeric types, right? So all those rules are addressed. And so I went back and measured the compile time for that, for using static analysis to solve that problem. And what basically we found was that it has to be slower. I mean, because you're doing something that you weren't before, but it was not measurable. We didn't turn off all the stuff that's happening. It's basically, we want to see what it looks like when you normally compile, the way you compile. And sometimes it's faster, sometimes it's slower, so you really couldn't see the compile time difference. So it was basically no compile time penalty to do that extra static analysis step to do the quality comparison. So that made me think of the Gordian knot story where, I mean, for years I've been trying to solve these problems with types, and that there was this other way that actually kept the simplicity and it kept the compile speed, and it's really easy to use, and it wasn't that hard. I mean, it didn't take us that long to implement it. So that was basically one of my other points I wanted to make, is that essentially types aren't always the right answer. But what we did, I mean, we have, I can show you an example of, we ran this on play and we submitted this pull request here. Let's see if I can find the code. And it's like, this is the code that's in play now, and this was in our pull request, because the SuperSafe said that you're comparing a seek a Boolean with a Boolean. It's really hard to see that, and they didn't have it in their test. I mean, it didn't catch it in their test code. So, usually when people try this, I mean, sometimes people don't find any errors, because if your tests are, normally you'll find this in testing, but sometimes it slips through. You would also find it faster if it's at compile time. But another problem that people have been complaining about for a long time, that I also tried to solve with types, is getting a type safe contains. And I actually came up with a way that you can get a safe, like a type error from a contains method on covariant seeks. So right now, if you just say list123 contains 2, well, of course it's true. Right here, if you say 2, it just says false, right? I've got a list of ints, and I'm passing in a string. Well, it cannot possibly contain a string, a list of ints, but you still get false, right? You don't get a compiler error. So I came up with a way with types to do this. But it's ugly. If you look at the safe contains method, it has this, it's like got an extra implicit parameter there that's ugly. This solution also relies on the current algorithm of type inference in a Scala compiler, which probably won't change, but might. So, and I also, there's already a contains method, so the only way to do this is have safe contains as an implicit, added implicitly, and I don't want to write safe contains, I want to write contains, right? And there's gazillions of lines of code calling contains. And it's not just contains, it's also index of, last index of slice, last index of slice. There's several methods with this same error proneness. So we tried that in SuperSafe, and that also, if I just say one, I don't know if I can get this to go, whoops, no. Apple makes this very difficult. All right, I'll give up on that. I'll just move it up when I finish. List123 dot contains 2. I think it's such a verbose compiler error, it actually moved itself up. you get the compiler. But this is not done. Basically, that passes the type checker. So then after that, there's this extra little check by a plugin that's just analyzing the AST and says, oops, this is one of these cases where it shouldn't compile, right? Okay. So, this graph here that I showed you is, again, the compile time of contains is the same thing. We really couldn't measure the difference, so it's really fast. And then the last thing that just did this past week is I was like, well, if I'm not going to do this thing with types, should equal should be should contain, because it's too slow and too complicated, could we do it with static analysis? And so we implemented one, and this is the first time we actually saw the time it takes to do it. For very, very large files with like hundreds of should be, we can actually see when it gets large, you can see up to 10% compile time, which I think is probably worth it for that. And if it isn't worth it, just turn off, you don't need to use this thing, and it's just as fast as it was before. So, essentially, this happened recently, and I think the Scala language attracted people who are interested in type theory and type systems and static typing in your programs, and I'm one of them. And so I like designing with types. But what I recently kind of came to conclude is that it's not always the best solution to every problem. So that's my other thing about the Scalactic Way, is it's use types where it's practical to achieve quality, but sometimes it's actually going to be more practical to use requires, and sometimes it'll be more practical to do something else or just not solve the problem. Okay, so just a real quick, like super safe, we just solved this one problem, no one else had solved it, and we released it. It's free as in free beer, which is appropriate. Free as in free beer. That's not a dismissal, but it runs with reduced features unless you buy a license key, which is $60 for a year. So it's basically what I'm trying to do is see if is give people a way to support the Scala Test and Scalactic open source projects, which actually does cost us money. We pay people to work on it, and but that would help you actually be more productive. So what it does, it's designed to be run all the time, so it can only do things that don't hurt compile time, at least not in a way that is not worth it, that time. So there are some static analysis that could take a long time that you wouldn't want to do all the time. You do it now and then. So that wouldn't go into this tool. There are no warnings, it's just errors. Like the other thing is, like, if there's a bunch of warnings, you'll just ignore them. So it has to be only things that I'm sure are wrong, and so the goal is no false positives. So it's less a linter and more like what you do is you define a subset of Scala that makes sense for your project, and then this enforces it. So the subset might be, I can only make sane invocations of contains, for example. That actually means that, you know, valid Scala, list123 contains the string 2 is valid Scala. I'm going to use a subset of Scala that doesn't actually have that in it. Okay, so that is my talk, and before I go to questions, I'm going to pass out we want to give away free copies of Scala Puzzlers. I think I should do this with my hat on. No, my hat, actually the hat was the signal of beer, so I'll do that at the end. But this is our latest book, and it's a really great book, and it's a lot of fun and very educational. I learned a lot from it. And so we have these little things that you can make into a cube, so I'm going to flip them out in the audience, and if you bring them tonight or tomorrow, we'll give you a free copy. Well, see, what's going to happen is I'm going to have to try to aim way to the back. You can jump up. Yeah, is that a question, or you want to, okay, you want me to, it's going to be tough. Maybe I should go, let me see how far I can go, and then I'll go down. Okay, that's not, I'm going to have to go out here, hang on. All right, this part. Oh, that's like the empty chair. Oh man, that was a good one. Okay, I'm gonna have to go all the way over there. Sorry. Yeah, you're gonna have one. He asked. All right. And to the front. All right. See, you have to ask in life. So, okay, that's it. So, any questions? I think you have to come up to the mic. Yeah, I know his question would be, can we go have beer now? Yes.
This might be kind of a dumb question, but I've noticed that with list in the Java collection and obviously the Scala collection,
yes,
the except contains and those other functions you were mentioning,
yes,
they accept any or object for Java's case. Why?
Oh, that's a good question. So I'm going to show the signature. I don't think I need to repeat that question because you heard him. He was on the mic. So I'm just going to go to list. There's list and contain. It was the contains method, right? Okay, so list is a covariant in its type parameter A, which means that a list of int is a subtype of list of any, for example. So the contains method, if you actually tried to, right here, what you really want to say is that this has to be type A. Sorry, it's popped up something. Basically, the element you pass to contains, you want it to be A. And you want the compiler to say it has to be, if it's a list of int, it's an int. If it's a list of elevators, it's an elevator, or some subtype of elevator. So if you actually do that and try to compile it, the compiler will say, sorry, you can't because you've got a covariant type parameter and a contravariant position. And what it's doing is making sure that nobody can make a contains method that could blow up at runtime. So if you don't, then it's possible for someone to write a contains method that then blows up at runtime. So it's not sound. So what they do instead, it's not an any, it's like a B. Instead of A, it's B, but B has to be a supertype of A. So that's how if you add, for example, if I have a list of, let's say I add a double to, well, let's just say nil. Nil is an empty list. That's a list of nothing. I can add an int to that, and the least common supertype of int and nothing is int, so now I get a list of int. And I can add a string to that, and I end up getting the least common supertype, which is any, right? So what happens is if I say list123.contains string, it tries to find the least common supertype between int and string, which is any. And so it's basically the only way to get around that is to make it invariant. And so like Scala Z has an I list, which is an invariant list that doesn't have that problem, but it's not covariant. And Paul Phillips has made Seeks, in his little library that he's made last year and a half or whatever. He's also got that kind of thing going where he hates this problem, and the solution is to use an invariant list. So what I did is I said, well, I mean, basically, but for better or for worse, this is our list. It's the standard list. And what you can do, though, is if you actually use a static analyzer, you can just get it not from the type system, but you don't get a type error, but you do get a compiler error. Yes?
So you said that Scala check is opinionated, right? And Scala test has a bunch of ways to write your test.
Yeah.
In your opinion, what is the best way to write? Because you know how you can write them in like RSpec format or
Yes.
flat spec?
Yes.
So I always find myself in trouble, like which one should I pick?
Yeah.
So in your opinion, which one is the best?
Okay, so I wrote the library. So my opinion is that the right way, and that's the opinion of Scala test, the right way to write a test is your way. Which, I didn't answer your question, but that actually is it, because I really think you need to pick something that fits the team, but pick one style, and then not have like a bunch of different styles in the same project, unless they're for different purposes. So it's not like, hey, it's Tuesday and I'm Fred, I feel like Fun Suite today. It's, the people who design the project pick all kinds of technologies. They should pick which style that project is going to do. If they're from Ruby, they might pick Fun Spec, because it's like RSpec. So that's how I dodge that question. So maybe we have time. Is there one more question? I think it's about time for me to close. Yeah, 1 minute. Yes, one more question.
Bill, does using SuperSafe seep into runtime at all? Or more specifically, does using SuperSafe does it result in bytecode that would be different than that which would be generated having not used supersafe?
Yeah, that's a great question. No. What it does is just gives you compiler errors, and then if there's no compiler error, the Scala compiler does the same thing. If it does give you a compiler error, you have to just rewrite it to a different kind of valid Scala, which is often fixing a bug. Sometimes it's just rewriting it to a better style that's more obviously correct. But then it's just regular Scala, it's compiled the same way.
Perfect.